In the last video, we set up our Xpenis project locally and we reviewed the starting base source code along with its front end. The plan for today is to do some data modeling because we need to create the starting entities along with its relationships. I'm going to be using an online app called DrawSQL to kind of visualize our database and draw diagrams. And no, this video is not sponsored by them. I just like it because it's pretty simple to use and it also has a free tier for public diagrams that have 15 or fewer tables. Xpenis diagram will of course be public, so you can clone it and adjust it or customize to your own needs. Alright, so let's get started. We know that our app is about tracking expenses and income. So we know that we will have at least the transaction entity, so transactions table. So let's create transactions table. And we also mentioned that we want to be able to categorize these transactions. So we're going to have the categories table and we'll fill in the columns in just a bit. I just want to create the tables first. We also want to be able to upload receipts to the transactions when creating the transactions. So we're going to have the receipts table and we're going to have a users table because we want to have user authentication. So at the bare bones and very least, these are the 4 tables that I think we're going to need. Now we may need more tables later on, but for now these are the tables that I think are good enough to get us started. Please note that I have not built this project yet, so I don't know what it's going to turn out at the end. I'm kind of thinking out loud and building this application with you. If you don't like such videos and you prefer more planning ahead of time, please do let me know in the comments. I just think that this is a better way because you get to see the whole process that may include planning, thinking, maybe researching, some bug fixing, and so on. So let's fill in the columns within these tables now. Within the transactions table, we know that we'll need some sort of description for the transaction, which will be a string. We are also going to need a transaction date. And of course, we're going to need the transaction amount. And the transaction amount we're going to store as decimal for now in the database side. And then on the PHP side, I don't know yet what we're going to do or how we're going to handle the money storage. We might use BC Math library and a third-party package, money PHP, but we'll do that once we actually come to that. I think that handling money requires its own lesson, so we'll deal with that when it's the right time. Some other columns that I think we're going to need here are the timestamp columns on when the transaction was created and updated. So created at date time and updated at date time. So the next table is categories, and for categories we're just going to have a category name and some created at and updated at date times. For receipts, I'm not sure how we're going to store the physical files yet. We might use S3, we might store it locally, we might use some other service. I just don't know that yet. We'll come to that when it's time. But for now, I'm just going to create a column here to store a file name and also the created at timestamp. Of course, we'll adjust these tables as needed once we actually start building things out. And for the users table, we're going to have email, which is going to be unique. So we'll set this to a unique key and we'll use the email as a username to authenticate the user. We'll also need the password. We need the name of the user and some timestamps created at and updated at. Now let's set up the relationships. We know that transactions will be categorized, so a transaction has to belong to a category. So it sounds like we need to add a category ID to the transactions table. So let's add that right here. And we're going to map these to the categories table. I'm going to draw the line from transaction to categories. And when we're doing that, let's see what relationship makes sense. Is it one-to-one, one-to-many, or many-to-one? So make your guess. We know that many transactions belong to a single category, while a category can have many transactions. So it sounds like many-to-one from transactions perspective and one-to-many from categories perspective. Now, because we drew the line from transaction to categories, we're going to set this to many to one. We also want to connect transactions to the users table. So that sounds like we need the user ID on the transactions table as well, because transaction can belong to a single user. So we'll add a column here called user ID, and we're going to connect it to the users the same way we connected category ID to the categories. The relationship here again is many to one because many transactions belong to a single user, but a user can have many transactions. So from transactions perspective, it's many to one. From users perspective, it's one to many. Then we also need to connect categories with users because somebody has to create these categories, right? And that's going to be users because user is the main driver in our application. User has transactions, user uploads receipts, user is the one who will be creating the categories. So we need a user ID on the categories table as well. And we can connect this with the users table, and the relationship here that makes sense is that many categories belong to a single user, but a single user can have many categories. So again, it's many to one from categories perspective, but one to many from the user's perspective. And the final relationship for now that we need to create is the relationship between the receipts and the transactions table. Transaction can have many receipts uploaded to it, but receipts can only belong to a single transaction. So we need a transaction ID on the receipts table. So let's add transaction ID here and connect this to the transactions table. From the receipts perspective, that's going to be many to one, but from the transactions perspective, that's one to many. In this case, receipts table is the owning side, so it's going to have many to one relationship. If this all sounds a little bit confusing to you, please refer back to the Doctrine ORM lesson where we go over these relationships to kind of refresh your memory. Alright, so I know our schema looks very simple as of now, and that is okay. We don't want to predict too much of the future. We don't know what else we might need in the future once we are actually working on the project and writing code. So we'll stick with this for now and add on more things or change them as the needs arise and as we're building out the features. Alright, let's open the code editor and create the entities. We're going to start with the user entities, so let's create a new directory here called entity and create a class called user. Now, as you might remember, we create entities by simply marking them as entities using attributes or annotations. We're going to be using attributes, so we'll mark this as entity and we'll also specify the table name to be users. Then we need to create the properties and map them to the actual table columns. So we're going to have the ID, we will have name, we'll have the email, password, and we're also going to have created at and updated at date times. Now these are just the properties. We actually need to map them to the table columns, and we'll do that by marking them as column. And the ID is a special column because it's an auto-incremented ID and the primary key. So we'll mark this as ID. And for the column options, we'll specify that it's going to be an unsigned integer. And we also want to make this auto-generated value. Next, for the email, name, and password, we're simply going to mark them as column without any options for now, and created at and updated at will still be regular columns, but we'll specify the name to be created underscore at and updated underscore at for the updated at property. So let's add transaction entity. Again, we'll mark this as entity here, change the table to transactions. We're going to copy some of these columns, so let's copy all of it, and we'll remove some. We'll keep the ID, we'll change name to description. We don't need email, password, we'll keep created and updated at, and we actually need another datetime column here called date, and we need the amount column. And we're going to use the float data type for now, but as I mentioned, this might change later on once we actually start creating the transaction records and start working with the monetary values. As I mentioned before, we might use something like VC Math Library and Mining PHP package because, as you know, it's not a good idea to use floats for monetary values. but that also depends on what sort of transaction amounts we'll be dealing with. Alright, so I'm going to leave the category and the receipt entity for you to create. So pause the video here and try creating both category and receipt entities. Just create the classes and the properties and map the properties to the columns. Don't worry about the relationships yet. We're going to set the relationships after. Alright, I hope that you gave it a try and you tried to create the category and receipt entities. If not, that's not a problem. You can just see how I did it. And here are the category and receipt entities that I created off the recording. So we just have a receipt with receipts table, file name, created at, and ID properties mapped to their appropriate columns. And then the category simply has ID, name, created at, and updated at properties, which are again mapped to the appropriate columns. So let's now actually create the relationships. We're going to start with the transaction entity. We established that transactions belong to a single category and to a single user. So it's many-to-one relationship from the transactions perspective. So we're going to create many-to-one relationship for the user and the category. So we'll have private user, and private category, and both of these will be many-to-one, and they will both be inversed by transactions. Now the other relationship that we need to set up here is actually the inverse relationship of the receipt, because we know that the owning side in terms of receipt and transaction relationship, the receipt is the owning side. So the receipt will have many-to-one relationship, so the transaction should have one-to-many relationship with the receipts. That's the inverse of many-to-one. So we go to the receipt, we'll set up here transaction, and this will be many-to-one, and it will be inversed by receipts. And we go back to the transaction and create a collection receipts property. So we'll have collection receipts, and this will be one-to-many relationship, which is going to be mapped by the transaction, and the target entity is receipt. So to go over again, when it comes to the user and category relationships from the transactions perspective, transaction is the owning side, and therefore we have many-to-one relationship. In the case of receipt, the receipt is the owning side, and we have many-to-one on the receipt side, but on the transaction, it's inverse of that, which is one-to-many. Again, if this at all sounds confusing, please go back to the Doctrine ORM lesson. I will leave the link in the description, so make sure to watch that to refresh your memory. Let's create a constructor here because we need to initialize the receipts property. So we'll do this receipts equals to new array collection. This collection is just an interface that array collection implements. So if we inspect here, we see that this implements the collection. Alright, so if you're up for it, pause the video again and try to implement the rest of the relationships yourself. So you need a relationship, inverse relationship of this on the user side. You need inverse relationship of the category, and you also need to set up the relationship between the user and the category. So give it a try and I'll show you how I implement this in just a second. So let's go to the user entity, and I've created these relationships here, and these are the inverse relationships. It's one-to-many. As you can see, this is mapped by the user on the category, and it's mapped by the user on the transaction. We already set it up, transaction entity, this user relationship right here. The transaction entity is the owning side holding the many-to-one relationship, and the inverse of that is one-to-many on the user entity, and that's what we have right here. And same goes for the categories. If we go to the category, we have many-to-one relationship with the user, because in this case the category is the owning side, so the inverse of the many-to-one again is one-to-many on the user side, and that's what we have right here. Now, as for the other relationship here, which is one-to-many for the transactions, this again is the inverse of the owning side many-to-one on the transaction entity. As you can see here, we have category many-to-one relationship, and the inverse of this is one-to-many, and that's what we have right here. Alright, so now that we got the relationships all set up, we need to add some getter and setter methods. Later we might change to use things like DTOs and value objects, but for now we'll just add simple getter and setter methods. Since I'm using PHP Storm, I can actually generate the getter and setter methods. So let's start with the user entity. Press Alt Insert, generate getters and setters. We'll generate the fluent setters, and we just have to adjust some of these. For example, we don't need a setter for the ID. The rest of these look okay. Maybe we'll adjust them later, but for now these are okay. But we do want to adjust some of these setters here that set the relationships. Instead of the set categories, I want to be able to add a category to the user. So we'll simply accept a category here. And what we'll do is that we'll simply do these categories, add category, and that's good enough. And we'll do the same thing for the transactions. Instead of set transactions, we'll simply add a new transaction. So we'll do add transaction, change this to transaction, and we'll change this to that as well, and change this to transactions. Now let's move on to the transaction entity and generate some getters and setters here as well. Let's generate all of them. Let's remove the set ID since we don't need that. The rest of these look okay, except the ones that set the relationships. We'll need to adjust the relationships. So here we're setting the user, and this looks correct, but because the transaction is the owning side, we want to be able to also set the inverse relationship, because we want to be able to add the current transaction to the given user entity, if that makes sense. Because right now, if we were to create a transaction entity and set the user, that user would not have this transaction set, so the inverse would not be set. And I like to set that on the owning side of the relationship. And because the transaction is the owning side in this case, we're going to set the inverse relationship here as well. So before we set the user, we'll simply do user add transaction, this, and this sets the inverse relationship. And then we set the user to the property. Next, we're going to do the same thing with the set category. We want to add the current transaction to the list of transactions for the category. So we'll do category add transaction, and this method does not yet exist on the category entity, which we'll create in a bit, but we'll set this way, and this should be good enough. Now for the receipts, again, instead of the set receipts, we're gonna have add receipts, because in this case transaction is not the owning side for the receipts relationship, the receipt is the owning side. So we'll do add receipt, accept the receipt entity here, and we'll do these receipts, add receipt, and we'll set the inverse within the receipt entity. So first let's go to the category entity and create the necessary getters and setter methods here. So we'll again generate getters and setters. Let's get rid of the set ID. Everything else is good enough except the set user part. And this is where we're going to add the category to the user. The same way we did within the transaction here when we were setting the user, we're adding the transaction to the user. So we do the same thing for the category. And instead of user, it should be this. And that's good enough. And instead of set transactions, we're going to have add transaction, which will accept a transaction entity. And we're simply going to add that to the transaction. And this is the method that we use within the set category on the transaction entity. All right, so we're good with the category entity. And the last one is the receipt entity. So let's generate the getters and setters here. Let's get rid of the set ID. And these look good. And for the transaction, we're again going to add the receipt in here because this is the owning side. So we'll do transaction, add receipt, this, and that's it. All right, so I think we're good to go here. Now I have no idea if this will actually work because I haven't tested it out yet, and we're going to do that in the following lessons. It's quite possible that I've missed something, or maybe there is a hidden bug somewhere here, but we're going to take it easy as I mentioned and build it up step by step, fixing the bugs along the way, because that's all part of the process, as you know. So before we end this video, I just want to generate the migration and actually migrate the tables, because we don't have the user, transaction, receipt, and category tables created yet. So we'll do PHP xpennies diff, and we're getting an error. Let's see what the error is. It says unknown named parameter type in transaction line 30. So let's go to transaction line 30. Oh, I have a typo here. This should be type. All right, let's test this out now. And sure enough, that worked. The migration has been generated. Let's inspect that quick, and we see that it's creating categories, receipts, transactions, and users table, and it adds the necessary foreign keys. Let's now migrate the database. So we'll do PHP xpennies migrations migrate, and that worked. Let's open the database, refresh, and sure enough, we have categories, receipts, transactions, and users tables. Alright, so the next step is to get the authentication working, because we need to have the user entity. Without the user, we can't have transactions or any other entity. Everything is kind of tied to the user. So in the next few lessons, we'll be looking into how we can create a simple authentication system where users are able to register, log in, maybe verify email, and so on. There are also a couple of security topics that I want to discuss in the following videos related to the authentication, so stay tuned. So thank you so much for watching. Smash the like button if you enjoyed it, and hit the subscribe button if you haven't already done so. I'll see you in the next one.